Our next presentation is by Danielle from Merck. So if you want to stand here, you want to use the mic?
I'll stand here.
All right.
Yeah. Thank you, and I'm happy to share how we are working to incorporate the allotrope framework into our biologics characterization workflow. So as part of the mass spec group supporting biologic analytical development, we provide mass spec supporting formulation, stability studies, upstream, downstream process, and we use a variety of different mass spec techniques, and this pilot was around our peptide mapping workflow, and that provides the highest level of detailed information about our molecules, confirming the primary sequence, identifying PTMs and potential hotspots in CQAs, as well as identifying product-related impurities. And so here I have a statement from our EPIC statement and kind of like our goal of this pilot. And so that was to have a comprehensive understanding of our molecule, including the PTMs, coupled with the run characteristics and archived in a standard format, increasing data integrity. And so I'm sure you can see from everything we've been hearing how allotrope can help with that. And so just to kind of walk through our workflow as it is currently, starting with the sample preparation, so taking our intact molecule, denaturing, reducing, alkylating, digesting into peptides, running reverse phase LC MSMS experiments with the high resolution mass spec in partnership with Thermo, and generating this data. And so the data processing, and so earlier we heard in the Framework 101 talk how much time, the majority of the time is spent analyzing and cleaning up, digesting this, data. And so how do we do that with our data processing? So it's usually in two steps, starting with software to help get an idea of what's going on with the molecule and using some manual steps to confirm and eliminate false IDs. So there's no standardized workflow in terms of how to process the data. And that's something that we would look to try to incorporate into our workflow. So I want to walk through how we use software. And in this case, we're using a vendor-specific Biopharma Finder software. So you input your protein sequence and you identify whatever modifications that you want to have the software search for. And you identify your component criteria, so threshold levels, peak widths, and things like that for the software, as well as mass spec identifiers, so your ppm error and different tolerances and things like that, that you'll have the software set the criteria for its search. And your output at the first starting point is a component detection. And so for this particular run, we had thousands of components identified. And from there, the software provides some sequence coverage, telling you an idea of how your run went and things like that, as well as a modification summary. And so here you would have an idea of what modifications were found associated with any hotspots on the molecule, and you could, at that point, manually confirm those. So reporting is also done manually, and there's no common format, usually a table shown here, something like this. And this is kind of detailing the sample, name, the modification that was identified, and the percent abundance for that modification. And there's no common format, like I was saying, so that's something that we also want to look to try to solve. That report is archived manually in lab notebooks or open lab or technical reports, so stored in multiple different places. So to summarize our current workflow using a combination of automated and manual data processing steps, generating data out of a vendor-specific software, and reporting and archiving manually. And so what are the needs there? I kind of was talking about that. We need to automate, and that will help us minimize transcription and user errors, as well as having a common output. So instead of having table formats different for each analyst, having a common format. Also capturing the metadata in one place so we can have better traceability and repeatability if needed for our experiments, as well as having our data archives with a common format in one place. And so with our proposed allotrope workflow, we would have a more fully automated data processing steps using the software, as well as utilizing the ADF to house all that information, the metadata, search results and everything, and then also put in an automated report generation step. So we wouldn't have the user or the scientist manually creating that report and archiving it. So Michael from Thermo helped us create this Biopharma Portal. And so with this portal, it's a web-based viewer where you upload your search results from that software, and you are able to download an ADF in a matter of minutes. And the data, the search results, the ADF, everything is housed in that portal, and you can view your data there and get an idea of your run statistics, signal to noise, spray stability, view the data, chromatograms, and everything there, as well as capturing the raw data, process data, and of course using the harmonized terminology from the mass spec working group. And so moving on to how we would try to take our manual report creation into a more automated step. And so currently, like I was saying, we would manually filter those thousands of hits into our table with, you know, tens of hits. And so some of the challenges that we had in terms of generating the auto report in collaboration with Ostis. So some of our challenges were the complexity of the data. There's a large amount of data, very information rich and requiring some manual interpretation. So how can we have a code that will automate that process? We needed to understand the nomenclature from the software, so really getting into the back end of how that software works, what it's naming these different components, so we can understand how we can filter these into our manual report. Additionally, understanding how that software is performing that calculation. I showed there's different ways to perform that calculation, either manually or using the software. So we need to understand how the software is performing that calculation so we could automate that and mimic that in the report. And having an understanding of if it's using summing multiple charge states or which mass it's using and things like that. And then, of course, the challenge of explaining this to you know, a non-SME programmer. And so this is kind of an idea of how our initial report looks. So here at the top, I'm showing a manual data processing step. So these values here, and then the output from the software. And you see great correlation there. But in our first try with the automated report, you know, the values were certainly not as expected, and certain PTMs of interest were not being filtered through. So, you know, working through those challenges, just to kind of show an example of how we were able to work through that. Looking in the raw data output from the software, we came to understand that there's actually multiple entries for an unmodified species. So if you kind of see this nomenclature here, understanding what that means, realizing that, you know, these are actually the same and would need to be summed to get an accurate calculation. And so those were some of the challenges that we incorporated and you know, were able to solve in creating our report. And so in the end now, we have an automated report that correlates well with other processing methods. And so in conclusion, we have incorporated this Biopharma Portal into our workflow. So it's vendor neutral, web-based viewer. We can view the data quality and easily recall the data would be housed there in the portal so you can track your data over time, as well as incorporating the ADF into our workflow, which, you know, houses all the metadata, you know, process data in one place. So helping to improve our data continuity and utilizing the common vocabulary and increasing our archiving and knowledge management. And also with the automated report, detailing the relevant PTMs and standardizing our report format, minimizing transcription user errors, and improved delivery to our consumers. And with the overall benefit for standardizing our workflow, improved efficiency and automation, and improved searchability. And I have a lot of people to thank for this partnership project: George Soder, who's the project lead, and my manager, Yanhui Liu, for her support in incorporating this allotrope framework into our current workflow, Michael for his support with the Biopharma Portal and the ADF generator, and the partners at Ostis for their help and patience in building the automated reports. So any questions?